Hey, let's look at some substitution reactions. So substitution is a type of reaction that occurs when a functional group is removed and it's replaced by another functional group. It's just like if you had a substitution in a sports team. One person is replaced by another. Now, halogens often are involved in substitution. They're highly reactive atoms, so often we are having the halogen that is being replaced, or the halogen is doing the replacing. So let's look at these 5 different examples of halogen reactions. So the first one here is when we have an alcohol and we're going to replace the alcohol with a chlorine group. Here, with the reagents we can use are PCl3, PCl5, and SOCl2, that is phosphorus trichloride, phosphorus pentachloride, or thiochloride. And what we're doing here is just all we're interested in, and we're looking at the group that is changing. That's the OH. We're adding a reagent to make the change, and this is this phosphorus pentachloride, and it's taking away, it's removing the OH and replacing it with a chlorine. So we've turned an alcohol into a haloalkane. And the second group of reagents do exactly the same, apart from, in this case, I could use hydrogen bromide, hydrogen chloride, hydrogen fluoride, and they will replace the OH with the halogen that is present in the hydrogen halide compound. So, for example, here we could have alcohol, which is ethanol here. We add hydrogen fluoride to it. It is the fluoride that is going to replace the OH. And we would have an extra product left behind here. It would just be water, because the hydrogen and the OH would get together. Okay, so we've turned an alcohol into haloalkane again. So the next one we're looking at here is we have a haloalkane, okay, and we are going to carry out a substitution reaction. We're going to remove the haloalkane and replace it with an OH group. And we'll do that by adding potassium hydroxide or sodium hydroxide, but they are dissolved in an aqueous solution. So what we do here is we put a bracket at the end of the reagent here and write AQ to say it's dissolved in water. So here, notice we have a fluorine attached to the carbon, or the first carbon here. We are replacing this with the OH that comes from the potassium hydroxide in the same position. And in these substitution reactions, the reaction is happening at on the same carbon, the same position every time. Okay, the next part here is we could take a haloalkane, and if we add concentrated ammonia or ammonia dissolved in alcohol, what will happen is we can remove the chlorine and we can replace it with an NH2 group. And what happens is a hydrogen from the NH3 is going to go away with the chlorine, and we'll get hydrochloric acid as well. And so we're replacing, again, off this first carbon, the Cl with NH2. The last one we have here is a substitution reaction. This one is a bit different in that there is no halogen involved, no haloalkane or alcohol. This is just an alkane. What happens here is actually this molecule is really unreactive, but if we put it in sunlight, ultraviolet sunlight will actually break one of these bonds and remove one of the hydrogens, and then the bromine will come in and it will take the position where one of the hydrogens were. It's important to note and remember in this case that the Br2, only one bromine is replacing one hydrogen in this example, and that the other bromine goes away with the hydrogen. Now, this is a common reaction. It's used to it's just used when we have to explain how we identify alkenes or unsaturated compounds. This reaction takes place over about 30 minutes in sunlight, and what will happen is that this bromine water that is an orange color will become colorless slowly over 30 minutes. And those are substitution reactions. Hopefully this video has been helpful. Look out for the other videos I have in this level 2 chemistry. Hey, thanks for watching this video. Hopefully this has made you more confident with your chemistry. don't forget to like, subscribe, or leave a comment about anything that you want to with this video or any questions you have. I'll see you later.